By now you're aware that our subject is weather. Weather related to forest fires. My name is Louis Allen, weather is my business, and my job is to get across to you the importance and the role that weather plays in the start and spread of forest fires.
The Weather Service provides forecasts on a number of scales to make sure that firefighters are getting the information they need, whatever type of incident they go on. The types of forecasts that we issue range from the daily forecast that's available every day, twice a day, to a specialized spot forecast if you're doing a prescribed burn or a wildfire that's just started, or an incident meteorologist can be on your fire, and they're a great resource for those things that you need to know about the weather. When you're out on a fire, you can experience a whole range of winds. You can experience the Groundhog Day effect of stagnant weather. Your incident action plan or your forecast says, okay, today is going to be like yesterday, not much change. Those are the types of verbal clues you're getting, that there's no real major weather system coming in that's going to change things. So what happens when you're out there and you're getting those verbal clues of, okay, today's going to be like yesterday, high pressure, not much change. You're actually looking for the convective winds. That's kind of a fancy, more technical term for when the sun hits a slope, it heats up, the air rises, and you start all these motions in place. And then when the sun sets, or it's not hitting on a slope, you don't have that radiation, so you're going to be a little bit cooler. And those little subtle temperature differences, they create wind. Up slope, up valley during the day, down slope, down valley at night. And that should be reflected in your IMET forecast or any spot forecast that you get. You're going to get squirrely winds. You're going to get things that are just a little bit different or in a different direction from what the IMET or that forecast has for your area. But generally they should be relatively accurate, those winds. So on a persistent day where you're heating up during the day, it's a nice clear day, no major fronts, no big cumulus buildups, you can expect those terrain-induced upslope, downslope type of winds. The second type of wind that you can get during the afternoon especially is called mixdown. When the sun starts to heat up the atmosphere, sometimes you'll hear it at your IAP briefing, we're going to have mixdown winds, or the inversion is going to break between 1300 and 1500 today. You have that mixing that occurs, and you have all the winds that are a little bit stronger above the mixing depth. And then as that inversion level breaks, all that momentum, all that oomph, all that push from the upper level winds can mix down to the surface. So what you're looking for out in the field to clue you in that that could be an important part of the wind equation that day is to listen to your IMET inversion level breaking, or we're going to have some stronger winds this afternoon, or expect the inversion to break at 1330 today. That's a clue that those types of winds can kick in.
A gradient wind is named because of the gradient that exists between a high and a low pressure system.
In the summertime, those changes may not be accompanied by rain, especially in the west. So you're looking for terms such as dry cold frontal passage today, or a weak cold front, or trough, low pressure. All those kind of signal gradient wind day. It's very tricky to assess how much of that gradient wind is actually going to be experienced on the fire line. If the storm or the front is powerful enough, those winds can surface, and they can take what is typically an upslope, downslope wind and drive it in the opposite direction. And then the last one, which is extremely important, is if you get those cumulus buildups, if you get a regular thunderstorm out there, you can have convective or thunderstorm winds. They can be very erratic, they can be very gusty, they're critically important. So if you're out there and you're noticing thunderstorms develop. Or even moderately, it doesn't even have to be raining or thundering. Moderate buildups, big, puffy, beautiful clouds might not be so beautiful on the line because they can induce some winds. Your standard cumulus buildup will give you a 30 to 40 mile per hour wind that wasn't there, and it'll come out of nowhere. The big thunderstorms, they can really, really cause some havoc because you can get 50 to even 80 mile an hour downburst dry winds out of those things. If you're lucky enough to have an incident meteorologist on your fire, you have the capability of having a localized IAP forecast or briefing. What's not going to be in that forecast is the exact weather at the exact time and moment where you're going to be on a specific division fighting the fire. Even though the forecast is designed for that specific spot, your IAP and your briefing is still going to be a more generalized type of briefing or piece of information. So when an IMET gives you that forecast, we're giving you a yardstick. We're giving you that, even though it's a yard, it's pretty specialized for your fire. The type of weather you're going to be seeing at the incident is going to be measured in inches and not the yard. Those inches are where your personal judgment comes into play. Are embers drifting up into the air instead of sideways? Are the winds starting to pick up? What are the tops of the trees doing? Are they swaying back and forth? Those types of clues should give you a kind of an instant brief snapshot, in addition to what the IMET gives you, that things are developing, things are changing, things are happening at that time of day. So what an IMET can't do is to give you that momentary snapshot where you are at that particular moment, the exact weather conditions where you're standing. You should have a 90% idea, but that 10% has to be filled in by your training, by your awareness, and by your situational awareness of the surrounding area. When you're out on the line and you're in canopy, you can pick up on some visual clues of how the winds are changing. If it's the morning, you can kind of take a look up in the sky to see if there's any cumulus clouds or any visual indicators of instability. If your atmosphere is absolutely clear, that can be also an indicator of instability. If you have little puffy, sheep-like looking clouds, they're actually called flockus clouds, a flock of sheep. You can remember it that way. If it looks like there's a bunch of sheep at 9 in the morning up there, it's unstable. And you can kind of expect that vertical movement of the wind later in the afternoon, or maybe even thunderstorm development, dry thunderstorm development. So what can you do as a firefighter to key in on these winds? First of all, listen to your forecast. Listen for the term unstable today or high haines today. That's the first clue. And you can combine that when you go out on the ground with your visual indicators. Smoke can actually inhibit winds. It can block out the sun so much that you're not going to get the convective winds. It's going to be very kind of a surreal, strange, you're in smoke and nothing's happening and you expect something to go, but it's so thick that nothing happens. But if you're in a run-of-the-mill fire where it's relatively clear, it's the afternoon and you start seeing that smoke, instead of spreading out horizontally and creating that layer, if the visibility starts to improve suddenly, if you see smoke getting up higher into the atmosphere, if you see it, punching through above the tree line and starting to bubble up, again, indicator that the cap is broken, that those winds could surface in a matter of 30 minutes or even 15 minutes. So watching smoke is vital. It can clue you in on when the inversion's breaking. You could get spotting in the direction of where that smoke is going, if there are active embers that are floating up into the column. So it's a great indicator. It's using that side effect of the fire to determine what your winds are doing. Feedback from the field is critical to performance, and just because a forecast doesn't work one day doesn't mean that you're not going to get quality, good forecasts later on. And those quality forecasts are only generated when we receive information back of how well we're doing. And if you don't give the data back, we don't know what's happening. And we can't build the database to improve the forecast, not only for now, but 10 years down the line. If you go back to that area, we have a weather record for that area. So not only are you helping your forecasts by helping us finding out how we're actually doing, you're building a legacy of making sure that future firefighters are protected from better forecasts from that data that you're giving us. Fire weather forecasts are designed to make sure that you are safe. And you can't be safe unless you have a little bit of err on the side of caution. We have a tendency to overwarn and overpredict for a purpose. And that purpose is to capture bad events and not miss them. And that results in some false alarms. It's better for us to overwarn and overdo it in terms of safety than to underdo the forecast. And then somebody says, that wind shift was unexpected. We didn't have it in the forecast. It wasn't there. Well, it should be there. We strive for it to be there, and it's a safety issue.
In the final analysis, however, you must add your own knowledge and understanding of fire behavior. As fire control men, the weather indeed is a very important part of your business.